Okay, with a pinch of salt. So why do we want to investigate microplastic and trace element contamination in sea salts for human consumption? So first of all, sea salts are harvested from seawater by natural evaporation. So sea salts might contain all the contaminants present in the marine environment. Secondly, production and food processing methods may also have an effect on the original levels of contamination. So are commercial sea salts on the European market contaminated with microplastics or trace elements? And if so, what are the implications for food safety? To answer these questions, we collected 15 brands of commercial food graded sea salts from Belgian supermarkets. And microplastics were extracted from the sea salts using a hydrogen peroxide treatment, and they were quantified using a stereo microscope. 5 trace elements, arsenic, cadmium, mercury, lead, and bromine, were determined using ICP-MS. So this is the first study on microplastic contamination in European food-graded sea salts, and we observed a varying amount of microplastics in the different samples. So our first type of salt is the industrial sea salt. And for such salts, the raw material, the raw salt, was washed with brine for several times to wash out all sorts of impurities and floating particles. And our study revealed a microplastic contamination up to 66 microplastics per kilogram of salt. So a second type of salt in this study was the traditional sea salt, such as fleur de sel. Traditionally, hand-harvested sea salts were harvested by scraping the salt from the salt pan without brine washing. And our study revealed a microplastic contamination up to 805 microplastics per kilogram salt. So here we may say that the amount of microplastics seem to be influenced by the brine processing of the sea salts. Now we will switch to trace element contamination. So first of all, cadmium and mercury were not detected in our samples. On the other hand, lead and arsenic were observed in most of the sea salts. And for 5 traditional sea salts, which are marked in red, the lead concentrations exceeded the safety levels of the Belgian regulation, but not the safety levels of the Codex Alimentarius. So these higher lead concentrations reflect the presence of lead in the marine environment, probably as an effect of human activities. For arsenic, all concentrations were below the safety levels. And for bromine in sea salt, there is no regulation available. All the observed concentrations of bromine were consistent with the natural levels of bromine in seawater. So we may conclude that current contamination of food-graded sea salts with trace elements is not harmful to public health, that the daily intake of microplastics via sea salts is low. If we take into account the advised daily salt consumption of 5 grams a day, this would mean maximum 4 microplastics a day. Still, it is important to mention that at the moment, no safety levels are available for microplastics in foods. And for further risk assessments, we want to advise to include the overall intake via the complete food baskets. So thank you.